Done, sir.
Okay, so let's do one question. Okay, oh no, you need to write that. Okay, so these are the properties. Next properties.
Done, sir. Sir,
Okay,
I already have these notes. You can just scroll down.
okay, and then we'll do numericals based on this one. It is a thin half ring of radius r equals to 20 centimeter. Uniformly charged. Total charge Q equals to 0.7 millicoulomb. Find magnitude of electric field. Okay, but where? That's what we need to know. At curvature center of this ring.
So is it millicoulombs?
Yeah, millicoulomb. 0.7 millicoulomb. Okay. Chandana, are you there?
Yes, sir.
Okay. So how will solve this, by the way? There is a half ring. Okay, so let's draw first half ring.
So we should use a formula of arc, right?
Yeah. So half ring. Suppose this is the center O. So suppose this all are positive charge particles here. Due to that, there will be an electric field, small electric field, dE. Let's take this as a x-axis. So dEx. Then this will
What's
be your
the angle? Like, what should we take the angle as?
something theta.
So we get the answer in theta, right? Like, because
Yeah, theta. So let's take small differential form, that is d theta. Okay, so if you want to find charge on this element, whatever element it is, so what we'll do? Small charge dq equals to q dl by pi r. Now, dl, for dl, if I need to take here, this is your dl here, small length dl. Okay, now to find this arc This is your radius into theta. So we'll get Q R d theta by pi R. R cancel. So Q by pi d theta dq. This is not over yet. Why we are doing this? To find electric field E d equals to 1 by 4 pi epsilon naught dq by r square. Formula. It is q by r square, but here small electric field, so small like a partial of it, like differential form of it. So if we take this all sum of all this small de in x direction, will give you total E equals to integral of dex. This is called net electric field. For understanding we are writing. That's it. We'll substitute everything here. But DE is also at angle. Okay. So that will come here, DE cos theta. So let's substitute this thing here and this one also here, everything. Cos component only, right? So it's falling this way, so it is cos component. Falling on x-axis, cos component. So when we are falling on x-axis, so it's varying from minus to plus. So minus pi by 2 to plus pi by 2, because we need limits also. Minus pi by 2 to plus pi by 2. So I'm writing directly. So it will become q cos theta by r square d theta. Yeah, we forgot pi also. Sorry, pi r square.
Sir, are there any options?
No. This is just questions. Okay, then integral of cos component, integration of cos is sine.
So is taking an integral compulsory, or we have any other way as well?
We have to take integral because we have to, this is for one small thing. So like this, we have to add all. Find the magnitude of electric field strength at the center of curvature. So overall, we need to find out.
Okay.
Oh, yeah, I forgot something like 1 by 4 pi epsilon naught. This thing I forgot. So 1 by 4 pi square epsilon naught r square sine theta pi by 2 minus pi by 2. Sine pi by 2. Sine 90 is how much? Sine 90 how much?
1.
1. And sine minus 90?
-1.
That's it. So minus plus, so it will become 2. So 2q by 4 pi square epsilon naught r square. Now we have all the value. Do we have charge and radius? Yes, charge and radius. Two into 0.7 into 10 to power. How much? Milli means how much?
9.
Into, yeah, and 1 by 4 pi epsilon naught is equals to 9 into 10 to power 9. We saw last class. So 9 into 10 to power 9 divided by what we left here? Pi means 3.14 into radius. Radius was how much? 20 centimeter. 0.2 square. Solve this. That's the answer.
Is the answer 100?
Okay. Do we get 100 here? Check. I don't have answers. We need to calculate. Just 2 and 2 can be cancelled. It's 3.14 and 9, 9, 6, 6 minus 2, 4, 4. No, this cannot be 100. This will be more.
Yeah, I forgot to multiply it with 10 to the power 6.
Okay.
Is it 10 to 2 power 8?
6. Yeah, it should be something like 10 to power 1, 2, 3.
Like when we multiply the whole thing, we'll get it as 126 divided by 0.126 multiplied by 10 to the power 6. So we'll get 100 into 10 to the power 6 plus 10 to the power 8.
Okay. 10 to power 8. Okay. So it's almost 100 into 10 to power 6. 10 to power minus 3, 6. Not 8. Or, yeah, 10 to power 8, we can say. Fine. Okay, but what about units? Chandana, remember what unit we found?
Voltmeter inverse.
Volt per meter. You got the answer?
So I'm still stuck near 100. Like I'm not getting more than that.
This you done, right? 2 into 9, 18, 18 into 0.7 divided by 3.14 into 0.04.
Yeah. Okay. I get it now. Sorry.
10 to power 6 will be power and remaining 10 to power 8. We'll do here next electric dipole. but it's not moving. Okay, electric dipole. Dipole. From name itself, we can understand it has two poles. Electric dipoles means they have two equal and opposite charge. Equal opposite charge. So equal means plus Q. Magnitudes are equal. Opposite means plus and minus. Separated by some distance. Not infinite, some finite distance. So equal and opposite charge separated by distance. It is called dipole. P equals to Q to L. This is called dipole moment. Okay, in 11th standard, you remember moment? Do you know what is movement? Not movement, it's movement. Can you hear me?
Yes, sir.
Okay. What do you mean by movement? Don't know? Chandana, are you
No,
there?
sir. No, sir. I don't know.
Okay. A simple way, like movement. Oh yeah, let's take example of like something. One rod is there. This is at hinge. Okay, this is a hinge here. I'm applying force here. So what will happen to this rod?
Okay, movement of force.
Yeah,
The turning effect of force.
exactly. So this will have what? Rotational form. Now you remember?
So it's like torque.
Exactly. So it will give you couple force here and this one. So position has changed as a turning movement. That is a movement. Simple. So dipole moment means force here is charge in terms of charge into distance. That is 2L. So it is not exactly what I'm saying here, but it's similar to that. To understand it, it's similar way, force into distance. So your charges are the force into distance. Okay, now we need to find a torque, how much torque it will give to get rotation form, to get rotational form. So in this, okay, yeah, before going that torque, let's see unit. How to find unit now, tell me. Get the unit. If you don't know, still make it. Both of you. Let it be right or wrong. Come on, try it. How to make unit here? Aditi, Chandana. How to make unit? Come on, tell me.
Coulomb.
Coulomb meter, because charge is there and we're multiplying it with distance.
Yeah, Coulomb meter. Now this is the vector quantity. Coulomb into meter. That's a vector quantity. Now vector quantity means it's required direction. So dipole moment required direction. Next is torque. Torque on dipole. Tau equals to QE into 2L sine theta. This is the dipole. Okay. This is theta. So it's rotated at this angle. So this will become sine component. So what is the length of this? 2L. So 2L into sine theta. Force equals to, torque is force into distance, perpendicular distance. So force is here, QE. Remember this formula, F equals to QE? So QE, 2L into Q will give you what? 2L into Q will give you? What is 2L into Q?
Dipole moment P.
Dipole moment P into E, or we can write here PE cos theta, or P cross E, sorry, sine theta. So remember, like this, wherever there is a cross product, it always comes with sine. Dot product comes with cos. Now, sometimes in your competitive exams, they ask in vector form. So let's check one question, not a question, like some formula wise question, something like that. So what if suppose P is given as P of X I cap plus P of Y J cap plus P of Z K cap, and E is given E of X J cap I cap plus E of Y J cap plus E of Z K cap. Now then torque will be I J K. Do you know how to find determinant? Have you studied? What's going on in your mathematics?
So like currently in this 12th class.
Yeah.
So for me, theory of equations and circles.
Okay. And for you, Aditi? A theory of equation circles. Are you in like
So
with
it's
Andhra?
two different types, 2 and 2B. So
Okay. Okay, okay. That's getting off. Then you might not know this determinants. Do you know
so
this determinants?
so like I guess they taught us last week matrix.
Oh, in Chanakya.
No, sir, in college.
Okay. In Chanakya, what's going on? What topic? Maths, I
Functions.
guess. Functions, relation and functions. Okay. Fine, 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 fine. Okay. So if you know or not, just check it. Like it's very simple. See, when you have three then simply do this way. Otherwise, if it is 1 or 2, then you can simply multiply and do that. Normal way how we are doing. But for 3, this is the easy way. I cap into multiplication of this one, py ez minus pz,
PZEY.
yeah, minus j, leave this one and this one,
PXEZ minus PZEX.
ex, plus
Plus K
last one,
cap is
so
PXEY minus PYEX.
minus pyex. So what I did here, this side minus this one. So first plus, second minus, third plus. This is easiest way to solve the, if it is 3. If it is 1 or 2, like no need to do anything like that. Okay, done writing.
Yes, sir, done.
Okay. What about Chandana?
Yes, sir, done.
Okay. Can you hear me? I got disconnected.
Yes, sir.
Am I audible? Okay, great. Okay, fine. So here, electric field due to dipole. Okay, so we will see some formulas. If dipole is kept somewhere, how it will behave. So if it is along axial line, okay, along axial line means uh here like this. If it is dipole minus q plus q, if it is kept somewhere here, p. So due to that, there is an electric field E also, and this distance is 2L. And from center, this point P is at distance x. So along axial means E equals to 1 by 4 pi epsilon naught 2px by x square minus L square. Now, similar way, if we have at some axis or at some point, not in axis, plus q minus q at some point from the center, that is LL, distance is x. This is point P. So for this, electric field at equatorial point equal 1 by 4 pi epsilon naught, same as usual, P x square plus L square to the power 3 by 2. These are two general equations for axis and equatorial point. This is your equatorial point. Equatorial point or line. Axial point means along the side, along a line. Equatorial means somewhere at the away point, equal distance from the both ends. Now, out of all this, one standard equation for any point. Now, this is the dipole, plus q minus q. Let's take small one, plus q. Any point from here, P, at this theta, distance x. So electric field along a line, resultant, and y-axis. So EY, EX, and E. So general equation for this one is 1 by 4 pi epsilon naught P by x cube 3 cos square theta plus 1 . Let's take one question with this. Then we can understand how to use this. So yeah, I know like this formula will be difficult to remember. But once we keep using now, then we'll remember. Because we have to remember so many formulas in physics. Tons of formula. Okay, let's take one question. And charge is what? 2 into 10 to power minus 8 coulomb separated by distance 2 millimeters. It will be always this this distance will be always very, very small. It is placed near long line charge of density 4 into 10 to power minus 4 centimeter inverse. Okay. Charge of density. Line charge of density. Okay. See, read this line. Understand this, what they are given. As shown in figure. Plus Q minus Q. 2 mm. 2 centimeter. such that negative charge is at distance 2 centimeter from line charge. Calculate force acting on dipole. So one formula we wrote yesterday, E equals to lambda 2 pi epsilon naught R. If we substitute here everything, we can get line charge how much? Okay, 4 in 10 to power minus 4 into okay, see, we have here 2 pi epsilon naught, but we know formula 1 by 4 pi epsilon naught is equals to 9 in 10 to power 9. So what can I do here? How to change this? So if I multiply by, for this case, if I multiply by 2 divide by 2, I can do that, right? So 2 into 9 into 10 to power 9 divided by r square. R square means, R means 0.02. So find this value. This will be 4, 5, 5, 2, 8, 36. 36. And this is 1, 2. 5 plus 2, 7, 7 plus 1, 8. 3.6 in 10 to power 8 Newton per Coulomb. Are you getting same value?
Yes, sir.
Aditi, what about you?
Yes, I got the same thing.
Okay. They said what? This electric field, nahi, they are asking force. So I found electric field, then if you multiply with charge, your work is done. F equals to QE. How much charge was that? 2 into 10 to power minus 8. 2 into 10 to power minus 8 into 3.6 into 10 to power plus 8. It will become 7.2 Newton because 8 and 8 cancel over. Finish. That's it. Okay, they're asking overall dipole. So this we found, let's name this as a 1, 1 for the first one. Same way, find for second one. Similar way. But distance, what would be the distance here? Total distance, okay? Total distance. Because first one is at 2 centimeter, second one is at 2 centimeter and 2 millimeter. So 4 into 10 to power minus 4 into 2 into 10, 9 into 10 to power 9 divided by 0.022. Next thing, you multiply with 2 into 10 to power minus 8. Now, overall net force is F1 will be greater, F1 minus F2. That is your net force. Get this one? You understood what I did here?
Yes, sir.
Both of you?
Yes, sir. So is it 0.6?
0.6. Are you talking about this one or net force or F2?
So net force. F2, I think 6.6.
6.6. Okay. So 7.2 minus 6.6, how much?
0.6.
Okay. Then it's correct. So this one you said it is 0.6. No, 6.6. Okay. Now this final answer you said, right? And what about this one, E2? Then it should be 3.3.
So it's 3.3 into 10 power 8.
Okay. Fine. So next class, tomorrow we'll do Gauss law, electric flux, this all things. Then we'll start doing our competitive questions first. Okay, this other we will do this. Yeah, these are the questions. We can solve all this. Nice question. Oh yeah, okay. Bye. Okay, guys. See you tomorrow.
Okay, so thank you.
Okay, sir. Thank you.
Bye-bye. Bye-bye. Bye.